Shouldn't have been that bad. All right, so let's look at this thing. Well, how many of you have seen the Thor movie? I saw it Friday. Really good. I never say that about Marvel movies. Like usually it's just explosions and like it's like a good enough way to spend 2 hours. This was by far the best Marvel movie I've seen. I was impressed. All right, so we are creating a bool expression and also a bool predicate. So let's go ahead and expand our parser first. All right, so our parser, and let's just clarify what these guys should look like. We would write a bool expression, maybe something like, well, it would just be a true or just be a false, right? That would be just the expression, just similar to const expression. All right, but it would be a single thing. So in here, maybe we put this guy up there near our, maybe under number, the next part of the filter. So we'll say, yeah, actually I wonder, does bool, okay, well, let's assume we didn't know that. So we'll say or equal exp true equal exp false. So if either of those are true, if it's true or if it's false, that means this guy must be a bool expression. So we'll say list bool exp and then exp. So that should be for our bool exp. Then we want to check for whether something is a bool, the bool predicate. So that's going to be more like these EQV ones. So kick it here. EQV car of exp is equal to bool like that. That's probably what we want the thing to look like. Okay, so if the car of the list is bool, because at this point, if I'm past those first three, I know I'm dealing with a list. So if the car is a bool, then I know this guy must be a bool predicate. And well, what would we write for a bool predicate? We would write. Do we have any other predicates? What do we say? We'll model it after that. So this would be a list of bool dash exp followed by parse expression cadr exp like that. Because a bool predicate would take in a single expression that would return true if that expression boiled down to a Boolean and false otherwise. So we do need to parse expression on this dude to find out if he, to find out what kind of animal he is. And we'll build this list under bool expression. All right, that looked legit enough? Okay. So now, so those are the two things for our parser. So there's adding a bool expression to our parser there, and here's adding a bool predicate to our parser here. Now we need to deal with those at the apply expression level. So here's apply expression. So maybe we'll put this guy right after our const expression just to kind of match up to what we did before. So EQV car parsed expression, and we call this guy a bool exp, like that. So if I'm looking at a bool exp, then what do I boil down to? The catter of the parse expression, which should be either the true or the false. All right. So just like that. So that's adding a bool expression to our dealio flippy thingy. All right. Otherwise, let's see, am I dealing with? We'll put this one after the 0. Keep our predicates together. All right. So if we're down here, EQV car parsed expression. We'll call this a bool question mark exp, like that. So if I'm trying to determine if something is a bool question mark exp, what am I going to compare here? I'm going to compare the result of calling apply expression on the catter, right, with the current env to true or to false. And did I specify maybe do this one with the let? I think you guys said you had to, right? Yeah. Okay. So we're going to do this as a let. So we're going to go ahead and we're going to say let, because what we want to do is we want to store the results of calling apply expression on the catter of this guy with the current environment, so we know what the result of that is. Because then we want to ask the question, is the result true or is the result false? Is it one of those two dudes? So we want to talk about that result more than one time, and rather than calling apply expression two separate times with the exact same inputs, we'll call it once and store the result. All right, so we're going to go ahead and say let, let's see, what is it? It's a list containing two lists, right? So let's just do let result be apply expression, passing it my parsed expression, which is a CADR of parsed expression, like that, and the current environment. So result will equal that guy. And then the body of that let, I have to think about what to kick this down a line. Let's leave it like that. So the body of that let will live in here. And this is where I want to do the or. So I'm going to return or equal result true. Let's see, what will a bool expression? It'll boil down to just a true or a false. Equal result false. So that's the body of that let. Should that do it? Looks reasonable enough. I say to do anything else there? For Boolean expressions, bool exp must implement as let. Okay. So not too bad. Let's go ahead and test this dude, make sure it works. So we'll come up here to our let's start off with our bool expression. So we'll say P1 is going to equal, let's see, we're doing it like this, right? And then we'll parse P1 and then show parsed P1. So if I give it a true, this should be a bool expression with a true. If I give it a false, there should be a bool expression with a false. What's it complaining about? Oh, equal only works for numbers, so, well, we could use EQV there since that's what we've been using for everything else. I think EQ would actually be enough. And I think earlier I mentioned that there's one called equal that measures like bone structure, and we'll need that later on in the semester. All right, so that's in parse. And then we need to do the same thing down here. Like that. All right, so here is our bool expression. So it figured that guy as a bool expression, good enough. And let's just make sure it works for the false as well, just for completeness. It should be another bool expression. All right. Now we want to send that expression into the bool predicate, right? So we're going to say bool that guy. Quote. So here's a bool expression on its body. which is false, and it boiled down to true because, yes, that guy is a bool expression. If I change this guy to true, it should also give me a true. Look good? Good.
Can you go back up to in Parse Expression where you need to
Parse expression. This guy right here. Here's my predicate right here. All right, so now we should be able to, now that we have this ability, well, by adding Booleans to our language, what now can we do? How do we just upgrade our programming language, our current version of our programming language? Our if expression feels more like an if expression at this point. Even though we're still relatively limited on the types of questions we can ask, we can now ask questions that have true or falses rather than assume it's the zero. So why don't we go back through and make a second pass now on our if, and clean that up a bit, right? Because we made an assumption we're in parse, right? Okay. We made an assumption last time where we asked this question, if expression, am I in apply expression? So this is our Boolean. Weren't we checking to see if it was equal to 0 last time, or did we rewrite it? Oh, I was always passing the 0 predicate. So we already wrote our if the way the if should be written. We're very limited on what we could pass it before. Okay. So now what we can do is we can test our if by passing it in things that ultimately boil down to a Boolean, right? So we can pass this guy our simplest form of a Boolean. Boolean expression is either true or false. So we can pass this guy into true. So let's go ahead and let's write one of those. So we'll say if true, then why don't we just keep it simple? Then 5, otherwise 6, like that. Okay, so if this Boolean expression boils down to true, give me a 5. So this guy should give me a 5. There's my 5. If false, now this guy gives me a 6. Okay, so upgraded our language. We're still limited, but unlocking that Boolean type, even though we haven't officially said it's a type, because we're kind of a type inference engine at this point, right? We haven't officially written something that we would call a type inference engine, but at this point we're saying we're not doing any error checking. We're just saying if you're a Boolean, we're going to deal with you like a Boolean, right? Because we have that ability in the language. What would be the next logical step in your mind for us to be able to ask? Because right now our limitation is the types of questions that we can ask are very limited. If we go back to the first thing we ever talk about with programming, at least if you're in my classes, how do human beings solve problems? We remember crap, we ask questions, and we do repetition. That asking questions part is a core feature of all programming languages, right? Therefore, shouldn't we pay pretty close attention to, we want to give ourselves a lot of ability to ask all sorts of questions. So what would the next logical thing be in our language? If you were this language writer and you were going to say, what should I write next? What could be the next thing that would make my language a lot more useful? What would you choose? Recursion. So you're going to jump from this to recursion? Explain. No, it's okay. I want to go to recursion too. Should we just? We could just stop class now and just say, implement recursion for Wednesday. Okay. Pretty big leap. But soon. Oh, you're gonna be so happy soon. But not happy. Yeah. But comparison. Like, give me a couple examples. Greater than, less than, equal to. kind of our primitive numeric comparisons, because we already have numbers, right? So it would be kind of cool to ask, is this number less than this number? Helpful, right? We don't really have some of the abilities. Well, that's probably the lowest hanging fruit is the next thing. What might come after that if we're just thinking ahead? So I can ask the questions like, is such and such less, is some number less than another number? What would be the next thing after that? Keep going down that exact same path though, because we're talking about building Boolean expressions. Okay, let's think about Java. What are my different operators for building Boolean expressions in Java? Got the comparison ones, the less than, the greater than, double equal sign, the equivalence dude. How else can we build Boolean expressions? Ors and ands. Yeah, our logical Boolean operators that now allow us to operate on Boolean expressions. Just by adding those things, I mean, it's not going to be all that difficult, right? Mostly we're going to be writing them in terms of scheme. Okay? But all of a sudden, our little mini language has all sorts of more power than it had before because now we can ask more interesting questions, therefore writing more interesting programs. Okay, so let's go in here. Well, first of all, we're going to have to build it into our parser, right? So let's give ourselves some comments down here, what we want to add, so we can kind of pre-plan it. Because now we're starting to get to the point where probably do want to think about things a little bit before we just start throwing things into our parsers and stuff like that, because parsers are getting a little bit scary. Actually, another thing I want to do here in the middle, it's let's gut things that we're not using. This guy, he is not part of any of the current things we have, right? That was from another homework assignment. Apply math express, huh? Yeah, it was oh, that was right, it was a quiz. Yeah, okay, so that's not part of our parser. Parse prefix expression is not part of our parser. Get next prefix expression. There's listo stuff too. That function, parse listo stuff. Oh, that's the one where you named the function wrong. Oh, that was a quiz too. Listo stuff? What was the one where you named the function wrong?
Yeah, it was listo occurs.
Oh, yeah, that's when Andy's dad was here. Yeah. He was very upset about your, what would we call it? What was he upset about? That makes something, you gotta catch me. Save me. He was upset at you. He was upset at you, is what he was. Let's see, where are we at? Unparse expression. Now, these are our old expressions. Unparsed and parsed, that's for the old lambda calculus expressions, right? So those aren't part of our current dealio. List contains, occurs free, occurs, listo binding. Was it listo bindings? Listo occurs. That was the one. Very upset with you about that one. That's what he was. He texted me. Get operand, get operator. Oh, these are our constructor things for our lambda calculus expressions, right? There's has binding. Do we use that in our apply env? We definitely need apply env. Extend env2. I don't think we use has binding, but before we dump that, let's just do that. And here's that extend env2 star. That's for multiple. Well, actually, why don't we leave those extend envs in there because those might be handy. Let's leave it like that. We're not necessarily using this guy yet, but we might. He might be handy. At the very least, we've cut down our starting point for our language a little bit without having all that extra crap in the middle. Okay. So a little bit of starting work there. All right, so we're going to add things like less than, greater than, less than or equal to, greater than or equal to, not equal to, and equal to. Those are probably the numeric ones that we want to have. All right, now how are we going to how do we want those to look? It's probably going to be something like a list containing like less than 5, 7, something like that. And we want to turn this guy into, what would we call the less than expression? Maybe something like that. Or LT expression. LT expression. And then not equals would be any expression, not equals. Good with that? Okay. So this will become LT expression. Then this is a const expression 5, const expression 7, something like that. So LT expressions take in 2 expressions. Okay, so let's go ahead and name these guys then. So we're going to call it LT expression. We're going to call it GT expression. Then less than equal to LTE expression. Greater than or equal to GTE expression. Not equal to any expression. Any expression. Get it? You want me to call it something else? How about NEQ, a neck expression? Oh, this is so much fun. All right, pick. What are we going to call it?
I say NEQ.
Exclamation point.
Not equal to expression?
That's nice.
How about a naughty expression? A note expression. Naughty. I really like any expression. Just adds a little humor to the language, right? All language builders like that. And then E expression. Actually, probably EQ expression. And then maybe this guy should be a not EQ expression. NEQ expression. Probably the most complete. So then we'll have to, this is more of a pronunciation thing when we say a neck expression. It's French, right? Is it French? Aren't you a French minor? I just made that up. No, him. You're not a French minor. You're a psychology minor.
Yeah, I was like, what?
Yeah, you're giving therapy to the French. Okay, so I've offended this half of the room. So I got to come back over. You're a tough one to offend, though. So I'm gonna set that bar high. So we're gonna work on that.
After you made fun of me for playing lacrosse, like the first class I ever had with you, like, I got over it.
Yeah, really?
Yeah.
Like, how quickly did you get over it?
After you're done talking about how dumb lacrosse players are.
Yeah, seriously.
Yeah, I agree.
That was when Kraus was still in school, right? You ever were in class with Kraus? Oh man,
He graduated the year before.
I liked Krausy, but actually I think it was Krausy is how he said his name. It's made up. What was I talking about? Oh yeah, dumb lacrosse players. All right, so let's go. Oh yeah. All right, let's go ahead and throw these into our parser then. So now, question: if we were error checking, which we're not, right? But if we were, where would we do our error checking? At the parse level or at the apply level? Parse level. Yeah. Think about when does Java scream at you? So if we think about it from an Eclipse perspective, we get the little red squigglies, the underlines, at the time of typing in the code way before we hit play, right? Okay, so now we do have that kind of other kind of error, that runtime error that was just hard to predict, right? So errors exist on both sides, but really a significant amount of our error checking happens at the time of parsing. But of course, since we're assuming everybody writes perfect code, our parser doesn't have error checking in it. I mean, it's going to be either me or Annie coding in this, so we're fine. But if we get anybody from this half of the room, things get sketch real quick. All right, so we're going to go ahead and add in. So we'll definitely be dealing with a list-based thing, right? So it's got to come after these first three. because these first three assume it's not a list. So once we get past those first three in our parse expression, we know we're dealing with lists of stuff. All right, so we can start using that same pattern as we have below, the EQV, car, EXP, and if it's a LT, actually no, this guy's the parser. So if it's less than, if that's the dude that we see in there, then what are we going to do? We're going to create a list called, well, with an LT EXP in it, followed by what? Somebody usually doesn't answer. That way I'm just not doing all the work. I want our brains to be engaged here. Scroll down here. What does a less than guy look like? He's going to look something like this, right? And if he looks something like that, parse expression is going to give me something like this. So if the car of this guy looks like one of those dudes, I'm going to create a list whose first element is LT expression, and what's the rest of it? The returns on the CADR and the CADDR, right? So we're going to call parse expression twice on the two other dudes. Parse expression, I'm lost right here. So we'll create a list out of LT expression, then out of parse expression. Now, why don't I have an environment inside of parse expression? Say anybody else who doesn't answer very often. I have an environment I'm passing around in apply expression, right? Why don't I have one in parse expression? Yeah, why not? Yeah, I'm reorganizing stuff, right? I'm meta tagging our information that's coming in. There is no environment at the parsing point, right? The parsing point is just flagging things as being things that were to make it easier to process later on. Environments don't come into play yet. So we'll call parse expression on the catter of EXP and parse expression on the CADDR of EXP. Like that. All right, so that's what I do for less than. Let's go ahead and steal this guy because we're going to repeat this several times, right? So let's do maybe less than or equal to. This is an LTE expression. And then let's go greater than. This is a GT expression. And then let's go greater than or equal to. This is a GTE expression. And then we have a not equal. That's a neck expression. An EQ, as they say in the French. Where did he come up with that? I think they do. We got French classes, I think, don't we? Oh, we have to have French classes here. Nobody knows whether we have French classes? Really? And we got Latin and Greek and stuff. We don't have French. There's Bibles in French. Are there French Bibles? No, I get it. Yeah. But I don't know. We have German classes. Is that just more of a Lutheran thing?
We have Chinese classes.
Yeah, we have Chinese classes. So Chinese makes just as much sense as French. Yeah, we have sign language. I like watching that the shows on the cruise ships. They at least several times on the Disney cruise ships. They definitely have it. They have people go up there to do the sign language, and they're acting out the whole like you're watching a musical, and they're acting it out. They're doing this whole. It's interesting to watch the sign language people. Like many times, that's the better show. No, I don't know. Some of those things seem like it would be very difficult to express. My wife wants to learn sign language. I don't get it.
If you're going to take sign language, don't take it as a night class. 3 hours of sitting in complete silence.
Oh yeah, you can't talk in there? Is that like a rule? Not allowed to talk in the sign language class? Like any questions you ask, you have to ask in sign language?
I don't know. I heard that in that class you also like spend a lot of time talking about like the deaf community too.
I see.
I don't know. Being deaf isn't like a liability or a disability. That it's a way that God gifted you to be.
Okay, that's fair enough.
It's only offered as a night class.
That's what he's saying. So he's basically saying, don't take it. If we translate what he said, we parse it, and then we apply that expression. He's saying, don't take that class. Yeah, I don't know. My wife wants to take it, so at some point I'll probably feel like with my tremors in my left hand, I might like start saying bad words and stuff. Huh? No, well, not in. Yeah, I mean that would be the Tourette's version of sign language. You know, if your hand shakes the wrong way and you do the wrong gesture thing, and all of a sudden what you thought you said is not what you said, right? It's a thing. Trust me, it's a thing.
I think that, I mean, this is just what I've observed, but signing, it's just as important to sign as it is your facial expressions as well. So if you're signing something really awful, but your facial expression is showing something opposite, I guess, I don't know how it would come across.
Yeah, I gotcha. I wonder if there's comedians who are like sign language comedians. I'm sure that exists.
Yeah.
It'd be interesting.
Oh, like there's.
But would they have their own material, or would they be copying? Like, do you have like Ralphie Make sign language?
I would think that the only way that there would be somebody that's a comedian only signs would be if they're deaf. Otherwise, I would think that they would just have a translator. I don't think that most comedians would go to the trouble of learning sign language.
Yeah, it might be true.
Yeah.
It's a thing.
Sit up there.
Yeah, but does he have his own material, or is this a translator?
No, it's his own material.
Yeah.
Yeah.
And then I wonder if there's like ones that are like, would be like rated R and HBO sign language guys. Okay. How do we get to All right, so we knew the neck expression was going to get us one of these times. All right, so let's get our last one in here. So we have the double equal sign, and this guy we said was going to be the EQ expression. Is that what we said?
Mm-hmm.
Okay, EQ expression. All right, does that cover all of our thingies? I think. All right, so let's test these and make sure we're getting the right kind of dealy flippy. So let's go ahead and let's do like less than 5, 6, something like that. And we should get an LT expression. So here's our LT. This is just complaining because we don't have an else in our apply expression. So we're not wrong yet. This is the important part here. So we have an LT expression with a const expression and a const expression. That looks all right. Let's just test all of them to make sure we didn't make a screw up. So we'll do less than or equal to. This should be an LTE expression. LTE expression. Then we'll do greater than. This is a GT expression. Yep. Greater than or equal to GTE expression. Okay. And then we'll have a neck expression. There's our neck expression. And finally, our EQ expression. Okay, so now we need to apply these. We need to add these to our apply EXPs. All right, now with apply expression, does every parse expression we ever get coming into apply expression, does everyone live inside of a list? Do we have that element that we had in Parse Expression where the top 3 guys here, we were saying, well, are you a number? Are you a true or false? Are you a symbol? Otherwise, you must be a list of stuff. Does that exist in the apply expression? Or is everything that we send to apply expression always, 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 always going to be a list? It's always going to be a list. Why? That's what we did. We wrote it. We wrote parse expression. We specifically said we want to take whatever you give us and we're going to mark it up. And the way we marked it up is to encapsulate everything inside of a list where the car of that list tells us what it is. Right? So we know this guy is always going to be a list coming into apply expression. So now we need to decide where in here, if we're trying to organize our things a little bit, do we want to have that stuff? So I kind of put our 2 predicates next to each other here. Now predicates always return true or false. So maybe we put our LT, our numeric expressions kind of by those. Maybe right before it, something like that. Since these are more Boolean expression builders. So EQV, car of parse expression. If it's an LT EXP, if it's one of those guys, then what are we going to do? What's my response to an LT expression?
Check if it's less than the whatever applied expression returns in the getter and CADDR.
Okay, yep. So use schemes less than on apply expression on the CADR of parsed expression passing at the current environment, and apply expression passing at the CADDR of parsed expression in the current environment. Is that our less than expression? That guy will boil down to true if this guy is less than this guy. Now again, we're not error checking, so we need to make sure that it's a less thanable thing, right? You know, like you can't say is a let expression less than an if expression. That wouldn't make sense in Java, won't make sense here. Okay, Java will scream at us. We didn't do error checking, so you know, Annie and I are fine. The rest of you are not. Okay, so give it reasonable input. All right, so that's for our LT expression. LTE expression be less than or equal to GT expression will be greater than GTE expression is greater than or equal to oh, go ahead. Am I?
Like for the apply expression, are you supposed to have a parenthesis after first expression to separate the
I'm actually supposed to. I'm not missing parentheses. I'm putting that in the wrong place. I have the right parentheses just in the wrong places. Let me down again, Annie.
I didn't say.
Do you know how many times we've copied that? Do you know how many times we've copied that? that's
That looks kind of weird, but I didn't say anything.
Oh, you're trying to spare my feelings is what you're saying now.
Maybe.
Only the French. Those reminded me of what was it, Austin Powers? Remember the quote the dad had? You know, there's only 2 things that I can't stand in this world: people who are intolerant of other people's cultures, and the Dutch. I don't know why that popped in my head, but then again, I keep coming back to the French stuff, so who knows? All right, so let's make sure this guy's right. So I'm going to say less than on apply expression, passing apply expression, that expression along with this environment. And let's make sure that we're not going to pull a Corey here. And does environment come second? So we're good. All right. So we're okay. All right. So this looks legit now. All right. Yeah, but we had basically already done all of them before. So yeah. Thanks for that, Andy. So yeah, it's a thing. We have to redo all of these. See how much typing that is? Like almost none. All right, so now we do our. I want to do less than or equal to first, LTE. Then we'll do greater than. Then we'll do GTE. That's greater than or equal to. Then we'll do a neck expression. Not equal to. And then we'll have our EQ.
Saying not equal to is functions not defined.
This guy?
Yeah.
Okay. Let's see. Equal. Not. That should fix it. So we're saying not these guys are equal to. Surprised that there's not a not equal built into the language, but whatever.
Double equal is also not built in.
Double equal signs just could be single. That's equivalence for numeric. Okay, is that all of them? Okay, we should be able to run this now. And for double, well, here, let's just test it on less than. So 5 less than 6 should give us a true. 5 is less than 6. There's our true. Let's do 6 less than 6. That should give us a false. 6 is not less than 6. Less than or equal to 6, it should give us a true. Yep. Greater than 7, 6 should give us a true. Okay, greater than or equal to, well, greater than 7, 7 should still give us a false. Then greater than or equal to 7, 7 should give us a true. Not equal to 7, 7 should give us a false. Those guys are, it's not true that they're not equal to each other. And then equal to 7, 7 should give us a true. All right, fair enough. Seems like those guys all work. So now we can ask more interesting questions, right? We can ask questions like, if some constant expression, for instance, a constant expression, maybe I have a let, so let's look at something that would be a little bit more complex. Oh. Now remember, our lets only allow us to define one variable, right? So I could say let a equal 5 in the body of if less than a 10. Then let's just do it simply. We'll say, well, what do I want to do? Then let's boil down to A. Otherwise, let's boil down to false. That'd be a good one. So we're going to create a variable environment where A is bound to the variable 5. Then we're going to ask if the value of A is less than 10, which it should be, then boil down to A, which should be 5. Otherwise, boil down to false. So this guy should give me, finally, the value 5 as my answer. Ruh-roh. Parse expression. Did I write the let incorrectly? That's what I'm thinking. Is a let not written the way I wrote it? Do we have it as a flat list? Is it let A5? Yeah. So there's my 5. That's pretty bad when you don't know the syntax of your own language. Like we invented the syntax and then had bad syntax. Now let's go ahead and let's change the A to a 10. So now 10 is no longer less than 10. So this guy should boil down to false. All right. So now we're able to ask more interesting questions, right? All right. We decided the next thing that would make sense would be ands and ors. What about exclusive ors? What's an exclusive or? How's an exclusive or is different than an or?
One or the other, but not
One or the other, but not
both.
both. So it's similar to an or, but both things can't be true. But one of the two needs to be true. So an and says both sides are true. An or says at least one side is true. An exclusive or says exactly one side is true. Make sense? So for our language now, we want to add all 3 of these, the ability to do ands, ors, and XORs. And these are going to be in conjunction with Boolean expressions, right? These are our logical Boolean operators. So maybe this is going to be an and exp, an or exp, and an XOR exp, or some people erroneously call it a ZOR exp. I've never liked ZOR. Yeah, it sounds like something the French would say. Is it?
Yeah.
All of a sudden, he's like this expert. Tomorrow, like Wednesday, he's going to come in wearing a beret. Yeah. All right, so we're going to have an AND expression, an OR expression, and an XOR expression. And what would we expect as some examples? So if we said something like AND less than 5, 7, not, well, it's equal to 5, 6. This guy should boil down to, so 5 less than 7 is true. 5 equal to 6 is false. True and false is, that boils down to false. Or, I'm just going to steal this line. Would boil down to true. XOR would also boil down to true on that because exactly one side is true. Make sense? So everybody's clear on the difference between ands and ors and XORs, and this should be or. All right, so homework for next class, take this as a starting point and add the logical Boolean operators to your language. Questions, comments, concerns, bribes? Don't forget tonight from 6 to 10 p.m. in this room here is the Hackathon boot camp. So we'll be going through kind of a crash course on using Unity and bringing virtual reality into Unity. I will record it, but if you are able to make it, I'd encourage you to show up so that if you haven't had VR stuff before, that way I'm not sitting here talking to myself. So that's one thing. If you haven't signed up for the hackathon, my deadline was 2 weeks ago. Professor Lackler's deadline was last week. You have until 2:15 p.m. today. If you haven't signed up or you're going to sign up right now because we need to buy enough food. And I'm putting together teams. I'm going to be emailing out the teams today.
Ooh.
All right? Yeah.
Can you throw in Slack all the programs that you download?
Yeah, I'll give you everything you need later on today, including who the teams are so you can start brainstorming with your team. Okay, so if you have not signed up for it, and you have to, we really want you to be there for the entire time. If you can't be there for, let's call it 90% of the event, some people are saying, well, I can come for the morning, then you're leaving your team in the afternoon. So you might as well just do the penalty homework at that point. So even though I want you to have the experience, it is what it is. All right? Questions, comments, concerns, bribes? All right, I will see everybody on Wednesday. Hopefully I'll see some of you tonight.